No. Okay. We have x minus 3 over 2 squared minus 9 minus 16 is minus 25 over 4. We're going to get through these. Let's do this. See if we can do 2 lessons today. Solving quadratic equations by completing the square. So solve quadratic equation from vertex form. Okay, so here we are trying to solve for x. That's what we're basically solving for. So we're going to take the square root. Both of these, x is going to be equal to plus or minus 5. Both of those values squared would give you 25. So x is equal to 5 or x is equal to negative 5. That's what we're doing. Basically, once we have it in vertex form, we are here solving for the zeros. X squared, x is going to be equal to the positive square root of 23, and x is equal to the negative square root of 23. Okay, this one, x squared is equal to 0. X is going to be equal to 0. That's it. There's no other answer. This one, x squared is equal to negative 5. This has no solution. No solution. There's no number that multiplies to give you, by itself to give you a negative 5. Okay? X plus 3 squared is equal to 16. What we would do here is you would take the square root of both sides, right? You take the square root of this, square root of this. Okay? So you would get x plus 3 equals plus or minus 4. Because both plus and minus 4 multiplied by itself gives you 16. So therefore you have to evaluate this equation twice. X plus 3 is equal to 4 and x plus 3 is equal to negative 4. So we have x is equal to 1 or x is equal to negative 7. Okay? Next, we have this term here, so we're going to divide both by negative 2. We get x minus 7 squared is equal to positive 11. Okay, now we know x minus 7 is equal to 11, or x minus 7 is equal to negative 11. So x is equal to 18, or sorry. Should have been square root of 11, right? Because you're taking the square root of both sides. So plus or minus root 11 is equal to 11. So we get x minus 7 is equal to, x is equal to 7 plus root 11, or x is equal to 7 minus root 11. Or you could actually write this out like this. X is equal to 7 plus or minus root 11. You could write it out like that. Either way is correct. Okay, finally, solve x squared plus 6x minus 7 by completing the square equal to 0, by completing the square. So we need to create a perfect square trinomial. So I have x squared plus 6x. The term I need on the end here is 6 divided by 2 squared. So I need to add 9. If I add 9, I'm going to subtract 9. All of that is in brackets, and then you would deal with the negative 7 equals 0. So here I've really just added 0. That's all I've done. Perfect square trinomial, I'm going to square root this and square root this. I get x and 3. My sign is the middle sign, positive squared. This negative 9 gets multiplied by a, which is 1. So it comes out to be negative 9 minus 7 is still out there, equals 0. We get x plus 3 squared minus 16 equals 0. Okay, because it's given us equals 0, not y, we can keep going here, right? So we get x plus 3 squared is equal to 16. 16 comes over to the other side. Now we're going to take the square root of both sides. We get x plus 3 equals plus or minus 4. So we have x is equal to, we have x plus 3 is equal to 4, or x plus 3 is equal to minus 4. So x is equal to 1, or x is equal to negative 7. Any questions? For any of that? Yeah, Adrian.
So for the last question in example 1, what if the quadratic keeps like converting into decimals?
The last question.
1 and 3.
Which one?
1 C on the other page.
This one?
Yeah.
This to a decimal?
Yeah. Decimal.
Up here? Yeah, I wouldn't mind. It's easier to work with fractions when you're working with square roots, especially when it's a perfect square. So I would have left it as a perfect square, because it's hard to understand that 9 divided by 4 is 2.25. It's hard to understand that 2.25 is a perfect square as opposed to 9 is a perfect square and 4 is a perfect square. So I would have left it as fractions. Any other questions there? Okay, we're going to move on here. Lesson note 6.3. This one is not too bad as well.